Welcome to Failure Mode Identification Process Descriptions, and thank you for your interest. We hope you'll take time after this short presentation to explore the other Triad Unlimited presentations on YouTube, follow us on LinkedIn, and visit our website to see all our service and training offerings. Here we see the definition of failure mode identification, which is simply identifying and prioritizing the plausible failure modes for each asset or asset group. The key term here is plausible, which means a failure that has happened in the organization, or has happened to similar equipment or processes, or is considered to be reasonable by subject matter experts but just hasn't happened yet, or is required to be protected against by regulation or law. So what does the business get out of doing this function of failure mode identification? First, we're going to develop a toolbox of types of failure mode identification methods so that we have a consistent way that we go about identifying failure modes. And we're going to develop as many of these tools as we need to match the number of asset priority categories that we developed. In other words, we're going to have a tool that we use for failure mode identification for each asset priority. Then we're going to have some rules for selecting the appropriate tool from our toolbox. As we'll discuss in a moment, we are seeking efficiency by expending the most effort to identify failure modes that pose the greatest risk to the business. We want to document or describe failure modes at the correct level of detail when we identify them so we can link meaningful proactive tasks to them. Finally, given that we only have limited asset management resources, we're going to focus those resources on the failure modes that pose the biggest risk or threat to the business. Using your car as an example, we may have a failure mode of engine seized, and we may have a failure mode of seat cover dirty. It is obvious that we are more concerned with a seized engine since that failure directly impacts our car's primary function of providing transportation. And this prioritization of failure modes and identifying them sorts all of that out for us. Asset management processes are organized and they're sequential, but they're also flexible. And by that, I mean every business is going to have a way to identify failure modes. And every business is going to have to decide which failure mode identification tool they're going to use in different circumstances. Every business is going to have to document failure modes in a way that allow them to address them with proactive tasks. And every business is going to have to prioritize those failure modes so that they can effectively point resources at them. But, like I said, every process is a little bit flexible because not every business is the same. Not every business has catastrophic potential consequences, for instance. So what we do is we define the rules for the business by using these processes and documenting them to create that cookbook full of recipes that can be used to carry out asset management at any particular business. Here you see a curve that represents the effort involved with the different failure mode identification tools. On the y-axis, you see effectiveness of the method, and on the x-axis, you see complexity, or how hard it is to do. Effectiveness, of course, is how successful the outcome is. And then you see on the left a list of failure mode identification types. Beginning with number 1, regulatory compliance requirement analysis, RCRA, asset manufacturer requirement analysis, component failure mode analysis, and failure mode and effect analysis being the most complex and the most effective. So using these different methods and applying them to the different asset priorities allows us to direct and focus our resources in the most efficient way. In other words, we use the failure mode and effect analysis, the most complex, most effective method on the most highest priority assets. It just makes sense. You're not going to do an FMEA on every single asset that you discover. So each of these has advantages and disadvantages, but they're different in two primary ways, just the complexity of the method and the effectiveness of the outcome. Now, this is kind of a generalization, and there is some significant overlap in both areas, but it's safe to say that performing a full-blown FMEA will result in a more precise set of failure modes than walking down the asset to identify the components to determine how they fail, which is generally more precise than reverse engineering an OEM manual. You don't really need to worry about these different methods right now but simply understand that there are different methods used for different priority assets. Your organization will likely use different acronyms for the various methods, but the idea, again, is that there are several ways to go about this effort. When developing or identifying the methods that will be available for failure mode identification, remember that each method will be used in alignment with asset prioritization and available resources. It's a risk-reward calculation designed to ensure effort expended in this key area makes sense. The rule is simply the more important the asset is to the business, the more effort we want to spend in understanding how it can fail. It's clear now that we want to expend the most effort on the most critical assets. Fortunately, very critical assets usually only comprise a small percentage of the overall asset mix. What we do at this point is make some rules around the asset priority number, or the asset priority classification that is based on that number, in terms of what method we will use to find failure modes for that asset. We might make a rule that says assets classified as very high will always start at FMEA. We might make a rule that says assets that have a low asset priority will just simply do a regulatory compliance requirement analysis, which is basically doing the minimum legally required to maintain that asset. The rules can vary from organization to organization based on available resources and skill sets, but the idea is to consistently select and apply failure mode identification methods based on rules and reason. Now remember that parts fail, assets don't. Only parts can be assigned failure types, such as worn or leaking or damaged. Therefore, failure modes have to be described in a way that supports alignment of proactive tasks that actually serve to address the underlying part failure. What this means is failure modes have to be constructed at the part level using a convention of part name plus failure type. This consistency allows failure mode data to be sorted and grouped and compared across the business and promotes creation of accurate tasks that address each failure mode effectively. There's a basic rule for defining a failure mode at the correct level of detail. When evaluating a failure mode description, ask the question, can a proactive task be identified that directly addresses that entire failure mode? If the answer is yes, you're usually at the right level of detail. Now remember, this is about protecting ourselves from the consequences of failure. So brakes failed is not a failure mode because a single task cannot be created to totally prevent brake failure. However, a failure mode of brake pads worn is a failure mode that can be detected by a task that says to go measure the brake pad thickness and verify a minimum of 9/32 inch of pad material remaining. Now, when you build tasks against every failure mode, remember there's a lot of failure modes can be created for one asset. A lot of failure modes then the more complex the asset, the more failure modes you're going to have. So what you can do is after you go through the failure modes for the brake system, you can collect all those together and then presto, you have an entire brake system maintenance plan that you can use to maintain the brakes all together because you've addressed every single failure mode with a task. And these tasks taken together provide a very accurate, efficient, and effective way to go maintain your brakes. That's how it works. Now, just as we prioritized our assets, we need to prioritize our newly discovered failure modes. By evaluating a failure mode's severity, likelihood, and detectability, we can move toward classifying the failure modes in terms of what type of task we need to develop to ensure we accurately mitigate the potential consequences of failure. Evaluation of failure mode severity is best approached as a facilitated meeting of subject matter experts. Severity means the effect or consequence, rather, of a failure mode on the asset's function. Remember, only parts fail, and not all part failures have the same effect on the asset to which they belong. For instance, if we're considering the many failure modes associated with a car, we can intuitively understand that a broken latch on our glove box affects our car less than a seized engine. The more severe the consequence, the higher the priority. Likelihood is the probability of any particular failure mode happening. Now, this can be a data-driven exercise or a consensus decision among subject matter experts, which it usually is. But the point is that high likelihood elevates the priority of the associated failure mode. Detectability is how the failure mode is found out. Some assets, like smoke alarms or emergency diesel generators and safety relief valves, have failure modes that cannot be detected during normal operation because something has to fail for them to be challenged to operate, and we wouldn't normally know whether or not they'll operate until that first failure happens. Now, other failure modes become evident as soon as they happen, like a motor shorting out on a process line. But low ability to detect means the failure mode priority is high. Each category is assigned a numerical value, and the category values then are combined with the asset priority score to provide failure mode prioritization. The higher the priority, the more we care about the failure mode. Just like in our previous function, in RE2 failure mode identification, we have these four processes, and really what we're doing, again, is defining the rules for these processes. We have a rule that says these are the different types of failure mode identification methods that we're going to use at our business. And then we have rules for, based on asset priority, we will select a certain failure mode identification method based on this asset priority group. And then once we do that, we find failure modes, and then we have to accurately describe them at the part level to make sure that we can build proactive tasks that are effective in mitigating or preventing those failure modes, the consequences of failure. And then once we have all these failure modes built and they're well described, then we have to have rules for deciding which ones are most important so that we can effectively use our resources toward making sure that we don't have any suffer the consequences of a catastrophic or important failure. This concludes the failure mode identification process descriptions presentation. Thank you for participating.